you some hints about volume. The disk method we've talked about is pi r squared. And the note about it is in terms of the variable you're rotating around. So if you're going around, you're going to use dx if you're going around the x-axis or parallel to the x-axis. So it's in terms of that variable. And dy would be if you're going around the y-axis or parallel to the y-axis. And then the last note I would make about the disk method is there's 2 radii if there's a gap. There's 2 radii if there's a gap. So if you have a graph that looks like this, it's a parabola. Let's move this parabola up a little bit. So if you have a graph that looks like this, it's a parabola, and it's going to rotate around the x-axis, then you're going to be in terms of x, and you only have 1 radius. But if you change that to where you're going to look at this parabola and this line, let's change it from a horizontal line. From this line, you're still rotating around the x-axis. See the gap? So you have a longer radius and a shorter radius. So you're going to do the outer radius squared minus the inner radius squared. But you have 2 radii when you have a gap between your shaded area and the graph you're rotating around. So since this is my shaded area, there is a gap. There will be 2 radii. Going back to the other one, let's say I have a parabola here, and my shaded area is from A to B. Now you can see there's no gap, so there's only 1 radius. No matter which method you're in, the radius is always perpendicular to the line of rotation. So if you can get that, it's going to help you a lot. The radius is perpendicular to your line of rotation. So right here, my radius is perpendicular. So it's going to be equal to the function. And then you can deal with your outside lines. Your outside lines get involved in your radius. So if you're going to rotate around this line down here, you have your radius is the function plus that value. So the radius is perpendicular to the line of rotation. Let's talk about the shell method. In the shell method, we use the formula 2 pi r h, and we use the other variable. So we're going to use dx if we're going around the y-axis or parallel to the y-axis. And we're going to use dy if we're going around the x-axis or parallel to the x-axis. There's never 2 radii. So the radius is x or y if you're going around the axis, and it's x or y plus or minus an outside line if you're going around a line of rotation. So your line of rotation gets handled inside the radius, and your height is always the function. Sometimes it could be function 1 minus function 2. Again, your radius is perpendicular to the line of rotation. So if you can figure that out, it'll help you immensely. The radius is perpendicular to the line of rotation. I would pause and screenshot both of these, maybe rewind. These are the best hints I can give you. So consider this graph. Let's consider the fact that we have some parabola here and a line that cuts it. Now, if we're going to rotate around the x-axis like we did in the last one, this is going to be in terms of y because it's the shell method, so it's y and 2 pi r h. Big note here, because it's in y, we're looking at functions for x equals. So anything that says y equals at that time becomes a bound because you're in terms of y. So when you have constants in terms of y, they're bound. But let's look at this one. When I draw my radius, I always draw it somewhere in the middle right here. So my radius is going to be y because my radius is in terms of x or y because I'm going around that axis. So since I have the radius, the height connects the 2 functions or the 1 function. So in this case, the height is going to be, we're in terms of y, so we read it right to left. So that means my height is going to be the curve right here. So we're going to say the height equals the parabola. Since I didn't give you specifics, we're going to say generally minus over here, you can see where it touches and it's minus the line. So it would be an x squared equation minus the line. And then your volume is not too hard to figure because it's 2 pi, the integral from a to b, and you would have y parentheses, the parabola, minus the line in terms of y. In terms of y. So hopefully these hints will help you as you study for your test to help you separate them out. So if you didn't screenshot this before, I found that a screenshot or notes here would be helpful. There's the shell method. Here's the disk method. Oh, let me do one more for you on the shell method. This is the big key right here. Sorry, my highlight didn't work. Let me try again. This is the big key right here. Your radius is x or y if you're going on an axis, and x or y plus or minus an outside line if you're not going around the axis. So let's say we have this graph and we're going around the outside line out here. So let's say this is x equals 3. If you're going around the line x equals 3, you're parallel to y, so you're going to be in terms of x. Now look at this radius. The radius, normally, anytime you integrate, you're going towards the axis. So normally this would be x from here to here, because the x value changes as you draw it across. That's where you get the x value from. So normally, when we are looking at this graph of these two shapes, our radius would be x. But we don't want where the gray is. We want where the blue is. The whole length is 3, and the gray is x. So our radius is 3 minus x. So you have to stop and think about that. The gray is what we normally get with the radius of x. And the whole blue line is 3. The length from the axis to the line of rotation is 3. But remember that our radius is supposed to be perpendicular and touching our line of rotation. So in this case, our radius is 3 minus x. Now the height's not too difficult to see. Here you can see that the height is the line minus the parabola. So the height in this case would be the line minus the parabola in terms of x. So you would have y equals x squared. I guess that's a definite there, and y equals x. So if this was y equals x squared and this was y equals x, then our height would be x squared minus x. So you can see how the parabola works out there. All right, pay attention to this box. This is a big key. This, the fact that your radius is perpendicular to your line of rotation is your other big key. So if you can nail those things down, it'll be helpful. And I hope it helps. And good luck as you're studying. Have a great day.